Hello, everyone. Hopefully, you're having a good day. I thought Paul's keynote this morning was fantastic. Really enjoyed that and looking forward to continuing that on. We're going to let people roll on in here before we have Mr. Chris McCain join and do his session. I see the numbers still trickling up, so we'll give it another 20 or so seconds. Past 200, that's nice. Lots of interest in this event. And of course, we announced the global virtual event. We announced this morning about Connect happening all across the globe next year. So 5 Connect. So you can go to vmug.com and check that out. Multi-day event, and excited to be able to go deeper into content with our members, which is something they've been asking to do because, as you know, VCF has got a lot of features, and that is something that our members are like, all right, we have it. How do we use more of it? And with that, one of the features that you're interested in is, of course, anything around additional security. So our keynote speaker today for the lunchtime keynote is no other than Mr. Chris McCain. If you don't know Chris, he is a fantastic speaker. He has spoken all over the place. He's an international speaker. He was has been on Explore main stage. He's been on so many VMUG main stages I can't even count anymore. And his session is very interactive. I think it's going to be zero PowerPoint and all whiteboarding, which we know our VMUG members like. So without further ado, Chris, why don't you join us on the main stage here? There he is. Well, that's Andrew. We just tested all this and I promised it worked. There we go. There's Mr. McCain. Folks, I will
All
let him
right.
take it, but Chris McCain, again, he's a double VCDX international speaker and an application and security expert. He can answer all your questions, and we do have the Q&A line that Andrew will be managing as well. So now's your chance to throw those questions in there and get answered. With that, Chris, I'll hand it over to you. Take it away.
All right, Brad. Thank you, man. It's exciting to hear about the Connect news, that's for sure. Go from 1 Connect to 5 Connects around the world. Jeez, you guys are skipping the whole crawl walk thing straight to running. I love it.
That's
So,
right.
yeah, so welcome everybody. Thanks for joining the VMUG Global Virtual Event. As Brad pointed out, my name is Chris McCain. I'm part of Application Networking and Security. Joining me today as the Q&A master is Andrew Reichek, who also works in ANS. And so today we're going to talk about protecting your VCF environment from cyber threats. And we're actually going to be introducing a new, I'd say it's both a go-to-market strategy as well as something that we're building into the product that is very powerful for our end users. So I'm going to share my screen here and we will get going. So Andrew, I won't see anything but my screen. If you feel the need to stop me, go ahead and jump in there.
Yep, no problem.
All right. So yeah, let's start off just talking about what the private cloud is, right? And then we'll fit vDefend into that private cloud and share with you what we're doing to dramatically simplify the way that security gets added. So we'll start off here with our ESX hosts. And then of course, as part of your vSphere environment, you're also going to get NSX for your software defined networking capabilities. And you're going to have vSAN to be able to do storage. Of course, all of that sits on top of the traditional physical network that you need to run. And then across the top, we're going to have our management products. So our vCenter, we've got our ops tools, we've got our automation tools, right? Our fleet management, all that good stuff. So this is really what makes up our private cloud. And then of course, on top of that, we run our workloads, and whether they are virtual machines or containers really doesn't matter to us. But this is the new paradigm for Broadcom, right? Build a private cloud. Now, for us in ANS, we don't like to say build a private cloud. We like to say build a secure private cloud. This is not a situation of why would I? It's why wouldn't you? If you're going to be investing in building this platform, then you should be ensuring that it is a secure platform. For a lot of the customers that are repatriating workloads from the public cloud into a private cloud, we want to be sure that there's no change or reduction in the security posture as they move into a private cloud environment. So we knew that we had to build something that architecturally was very good, but we also knew that it had to be something that wasn't complicated. Oftentimes people associate security with complexity, and rightfully so. Where the tools that we had historically did not make it easy to introduce security into an environment. So the engineering that we've done has been a lot focused on the simplicity of being able to manage security at scale and doing it in a manner that really breaks from traditional norm when it comes to the way that policies are created. So I'm going to add to my drawing here the physical firewall that of course we want you to have, because I'm not here to tell you today that we want you to get rid of the physical firewall. Absolutely not. It is the first barrier to entry into your environment. But I think we're way past the point of debating whether or not a physical firewall is enough to protect the internal data center. I think we can all agree wholeheartedly that we need more. There has to be more than just that physical firewall. And so that's where we then introduce VMware vDefend. And if you are a longtime VMware follower, if you're one of our loyalists, thank you, by the way, you probably remember NSX. You probably remember that product of NSX that did both networking and security. Well, now, as I drew in the picture here on the right, the networking constructs of NSX are built into the very fabric of the VCF product. Well, the security pieces are now referred to as vDefend. So we do still share the NSX manager. We do still share the fact that we both live in the hypervisor, but the products themselves are being engineered a little differently. So we move at different cadences when we do this. And vDefend is an add-on to the VCF platform. So what exactly do we get with vDefend? We get the distributed firewall. We get the gateway firewall. We get a very super powerful tool called security intelligence. We get network traffic analysis. We get network detection and response. And then we get an IDS IPS capability. And I just want to point out that there are some of these features, the security intelligence, NTA, and NDR, that rely on a component that we refer to as SSP, the Security Services Platform. And I'm going to talk in depth about this because this is really the heart and soul of the go-to-market strategy and the innovation that we're doing to simplify the way security gets implemented in the private cloud. But let me start by just laying the foundation here and showing kind of what the architecture looks like for the gateway firewall, the distributed firewall, IDS, IPS, because it's very different. And the impact of this architecture not only impacts the way security is implemented, it will change the way customers design data centers today and moving forward. So the distributed firewall is the same concept as a physical firewall, except it's been abstracted into the hypervisor to run at the virtual NIC level of all the workloads running on the hypervisor. So it's in real time, layer 4 through layer 7, stateful firewall capability built into the hypervisor. And for those of you that are longtime VMware engineers, you guys are already familiar with the concept of the distributed switch. You guys are already familiar with the idea that we are passing the traffic from a virtual machine through the hypervisor to the VMK NIC that's then connected to a switch where we trunk all the VLANs, all that good stuff. So you're familiar with that. You understand the flow of that data. What we're doing is we're extending the architecture of the hypervisor to say, well, instead of just passing the traffic, let's give our customers the opportunity to inspect that traffic to determine if it should even egress past the hypervisor. And we do this without requiring any changes whatsoever to the physical network. So very, very important part of this. And the reason this is so important is because if we think about security within the modern enterprise, there is no one organization within the enterprise that is going to solve for the entire security posture of the company. It's not going to be virtualization. It's not going to be networking. It's not going to be the firewall team. It's not going to be the application developers. Every one of those different parts of the organization have to play some role, and together, collectively, organizations will be able to build a security posture that helps mitigate and minimize risk in the environment. So with the vDefend products, the fact that we do not have to make any changes to the physical firewall means that this tool is purpose built for the virtualization team. And realistically, if you're a company that's heavily virtualized, and I don't care if it's a small commercial entity like Grinnell Mutual that everybody saw on stage at Explore, or if you're Bank of America, it doesn't matter, because you have to be able to protect these workloads in a way that simplifies the operational model of security. And trying to do that using physical firewalls, trying to do that using agents is very difficult to do, because the physical firewalls add a level of complexity that means you have to change the way traffic flows throughout the physical network. And installing agents, well, agents impact other agents. So the fewer the agents you can deploy, the better. And if you see my drawing here, you'll notice that our firewall is not inside the guest. It's outside the guest in the hypervisor. So it definitely provides a strong competitive advantage. The other thing that I want to point out is that along with no physical network changes, the distributed firewall means that you can let go of the decade-old idea that IPs have a relationship with security. This is how we ended up with three-tier applications historically, because we wanted to be able to apply some level of security, but in order to do that, we had to traverse a layer 3 device. So what did we do? We built a web network and an app network and a DB network, and we threw a firewall in between to be able to control things. And we said, oh, okay, we're secure. But because of where we sit in the hypervisor, this is no longer true. And this is probably the most powerful part that impacts beyond just the security. Because if you think about this now, if I no longer have this relationship between IP addresses or IP networks and their role in designing security, it means that I don't have to rely on routing. I don't have to rely on layer 3 devices in order to protect my applications. So from a design perspective, I could design infrastructure that has a fewer number of larger networks, and it doesn't jeopardize my ability to control flows even within the same IP subnet. And that's huge. So distributed firewall in hypervisor, radically different architecture. Not going to lie, this is and always will be our competitive advantage. There is no other security vendor that is going to be able to leverage the hypervisor the way that we leverage the hypervisor. And that's a powerful statement. Okay. The gateway firewall. The gateway firewall is the instantiation of a physical firewall, or I should say an appliance-based firewall that can be done as a virtual machine or a physical machine. So this is really our way of being able to say, if you are 90% virtualized, you have 10% of your systems are not running on VMware, but you would like one single management plane to be able to control security in the private cloud, then you could deploy the gateway firewall as a physical machine or as a virtual machine and control flows between non-virtualized workloads. And there's also agents. There's some agents you can deploy in a limited number of operating systems now, but ultimately the DFW is going to be the best architecture. but we didn't want to have holes in the security story when it came to vDefend. So the gateway firewall and the agents are ways of closing those gaps and making sure that customers do have options when it comes to the way that they are managing security policy. Okay, let's pivot into security intelligence, NTA and NDR, as they are all part of this SSP that I mentioned. So SSP is a container-based platform. It is not a small entity by any stretch of the imagination. So it's not just, oh, I'm going to deploy one OVA and that's it. It has to scale because the value of SSP is in the data. SSP is a data collection engine. So every host where we are running vDefend is going to provide flow information, flow data to SSP. So SSP is going to have this giant repository of flow information. Now, having that information, no big deal, right? There's a lot of tools that have that information. The value of SSP is in what we do with that information, what we give back to you because we've collected that information. And by the way, remember, again, because we own the hypervisor, this is not spanning or tapping. We're not doing samples. We're getting all the flows about the environment. So security intelligence is a tool that can help you with your microsegmentation planning and implementation. Because we have the flows, it can see that, it can create policy. But more importantly, this is where our new strategy that we'll call vDefend 1, 2, 3, 4. 4 easy steps to be able to deploy vDefend and protect your infrastructure. So let's start with step 1. Step 1, and again, this is driven by SSP, is to do a segmentation assessment. We have all these flows, we're going to analyze them, and we're going to give you a score based on what we see in that flow information. So are you controlling infrastructure protocols and services? Do we see any type of macro segmentation, micro segmentation? So all these things, we're looking at the flows and determining if you've done anything now that could impact this overall assessment score that we provide. Step 2 is to start with your infrastructure protocols and services. So SSP, having this rich contextual information about flows, can assist you in being able to create policy that controls infrastructure protocols and services like RDP, which is used commonly for lateral movement, SSH, SMB, NTP, DNS, Active Directory, all things that are high value targets for an attacker in the event that they socially engineer their way or fish their way into your infrastructure. So the 1, 2, 3, 4 says, well, we're going to start with buying down risk quickly and easily by protecting these infrastructure protocols. Now, once these things are done, step 3 is to look at what can we do from a zoning perspective. How can we help customers reduce the blast radius of an attack by establishing zones for the different environments that they have? It might be production, it might be test dev, it might be a DMZ, but we know for a fact that we want to control flow. I'm not saying we'll block every flow between these different environments, because in some cases we do have exceptions where we want to be able to allow communication between different components. But so it's not about blocking everything, but it is about controlling. So defining these zones is a way for us to reduce the blast radius of a particular or a potential event by isolating it into one particular zone. From there, step 4 is when we start looking at our applications. Now, this does not mean specifically microsegmentation. Now, microsegmentation could be part of this, But before we get to micro segmentation, you may do macro segmentation, or something that folks may refer to as app ring fencing. So what do I mean by that? Let's look at it. So step one is the infrastructure protocols. These are non-negotiable. These are things that we are not going to allow exceptions to because of how vulnerable they are and how powerful they are for an attacker to be able to use. Now, when we get to the zoning environment, so let's develop some zones here. So I've got my prod zone, and then I'll get my test and dev, and I'll get my DMZ. And the way that these things are going to be zoned out is really a tagging taxonomy that makes it very easy to do, but more importantly, makes it easy to consume when you have new workloads. So it's not enough just to protect the things you have today. We want to make sure that you have the ability to modify the operational model in such a way that you can continue to consume the security architecture that is being designed. So in prod, right, we would create a tag, and tag equals prod. And we would create a security group that says if you have that tag of prod, you're in the security group. And we would just do the same thing for test dev, and we do the same thing for DMZ. And keep in mind that, we always have the opportunity to build exceptions. We have the opportunity to permit something in the DMZ to communicate with something in prod if it needs to do a data dump every now and then, whatever it might be. So you are not locked into just blocking the traffic at these high levels. But now that we have these security groups, we can build policy easily that controls the way that communication flows between these environments. So that's step three, the zoning. If we move to step four, when we look at our applications, again, I'm not going to jump straight to microseg. Now, realistically, if you wanted to, if you had a strong microseg initiative and you wanted to, you could. So these are not linear solutions. We put together the VDFN 1, 2, 3, 4 go-to-market strategy, and we engineered the product to support this simply because this works for 90+% of our customers. But if we have customers that say, hey, I need to start with microseg, I have a particular app, I want to secure the app, you could absolutely start there. If you wanted to start with any of the advanced threat prevention, if it's IDS, IPS, NTA, NDR, you could start there. There's no prerequisite here that suggests one of these things absolutely has to go first. But again, we wanted to build a prescriptive model that we could go to every customer. And we know that if you follow 1, 2, 3, 4, then you are going to end up with a security posture that is much better than before you started with 1, 2, 3, 4. So back to the story here. In 4, when we're dealing with applications, let's say that at a high level, I don't really want to get into the app level, but I know that within prod, I've got some apps that are regulated. So I've got some type of compliance requirement around it. And I've got some apps that are unregulated. So similar to the way we did the zoning, we could easily tag all of the systems that are part of regulated apps, and we could tag all the systems that are part of unregulated apps. And we could put them in a security group respective to their regulated or unregulated. And then we could build policy that prevents the communication. So ultimately, what we're doing in this model is we are slowly, through the creation of our policies, we are reducing the ability for a potential attack to go beyond a particular app ring fence or a particular zone. So smaller and smaller it gets. So we could take this a step further, right? And now we look at app ring fencing. Within my regulated apps, I have app 1 and I have app 2. And I don't need app 1 and app 2 to talk to each other. So what do? I can tag it. I can build a security group. And then I can build policy using those security groups to ensure that app one cannot talk to app two. Now, what have I done? I've shrunk the potential scope of an attack even further now. And keep in mind that I'm just using app one and app two. You could have hundreds of apps, but maybe you're not worried about hundreds of them. It doesn't have to be every single app. You get to pick and choose how conservative or aggressive. You get to pick and choose where this is going to get implemented based on where you feel you're going to get the most bang for your buck with the implementation of the security policy. So as part of this strategy, this 1, 2, 3, 4 strategy, you are still in control over the scope of how these things happen. We're just trying to make it easier for you to consume the product. We're trying to make it easier for you to be able to apply security. And we're trying to make it so that you can more quickly apply security. Because ultimately, if you think about the way security works, I'll just draw a little diagram here to explain this point. But let's say we look at security on this axis, and we look at time on this axis. If you were trying to secure your infrastructure using legacy type products, if we're talking about agents or we're talking about physical firewalls, what happens is it's going to take you some time. And then it's at one point, it's like, okay, now I feel good about what I did. But it's small iterative steps to get to a point where, maybe you've reached a level of security where you're comfortable. And then probably what happens is the more you do, now there's a diminishing return. So you can do a lot of little things, and then you get to a point, and then I'm secure, and now I'm even more secure, and then it starts to die down because every new thing that I do is not impacting to the same degree of, the things that I have done. However, if you look at the way vDefend, and specifically the vDefend 1, 2, 3, 4 initiative goes, it's a very different look, because what happens now is you actually end up getting security very quickly, and then you hit that diminishing return. So if you look at the time that it takes to get to that point where you feel secure, it is much faster with vDefend than it is using traditional tools. Again, because we engineered the product to do this. We thought about the way that security has been implemented historically, and we took advantage of our unique architecture and said, how do we create an opportunity for customers to reach that security inflection point where they say, okay, I feel good. I've done something. And so, I mentioned the virtualization engineers previously, that might be the point where you stop. You might say at this point, okay, I'm being a good corporate steward. I'm playing my role in the overall security posture of the organization, and I'm good with that right there. And that might be, steps 1, 2, 3, and some app ring fencing. Or you might continue on and go down that microseg path. And so if you get to that point where you want to do microsegmentation, well, we've made it easy to do that as well. And that comes from SSP. So SSP, having all the flow information, not only do the flows, but has the ability to generate rule recommendations. So you can, if you take a particular application, you tag the application, you tell SSP, hey, I need you to look at all these things with these tags, right? Because I'm really just focused on one app. I'm not going to microseg the entire thing right now. I want to focus on one app. So I can pinpoint what it is I want to look at. And I can say, based on these, what rule recommendations would you give me? And not only do we give you the rule recommendations, we give you the ability to just say implement it. That the push here button. But realistically, this is the hard part. It's not the rule stuff. We've taken, from a technology perspective, we have taken all the guesswork out of microsegmentation planning and implementation. We wanted to be sure that if this is the way customers wanted to go, that there was no roadblock in, I don't know how my things communicate. Because I'll tell you, that's historically, that's been the key, is that most customers, when they want to do microseg, they will say, I don't exactly know how my things are communicating. And I don't even know if it's right. The person who built this app is gone, or this is an off-the-shelf app we've had for years. We don't know. We took all that away. Now you know. Here it is. Here is the way things are communicated. The hard part becomes the pushing of the button, because you're basically becoming accountable for those policies. You're becoming accountable for the way that application flows. Now, truth be told, in a brownfield environment, our default security policy isn't any allow. So you're not going to break the application by deploying these rules. If there's a particular flow that you did not capture, maybe it happens once every 60 days, you're only looking at the last 30, it'll end up hitting this rule and it's going to be allowed. So me personally, if I'm the virtualization engineer, I don't mind pushing the button. I'm not afraid of breaking the app because I've got this default policy. What would concern me more is if one of the flows that we captured was actually a malicious threat actor that's already in the environment. And this flow happens to be something that they're doing that is not truly part of the application architecture. That's what I would be more concerned with than, oh, I'm going to break the application. Now, keep in mind also that if this is our default, right? Because most customers are deploying vDefend into a brownfield environment. But if you're deploying a greenfield environment and you want to go change that default to any drop, you absolutely have the right to do that. And I have had a few customers, not a lot, but a few customers that are doing this. And what happens now is, if you want to bring your workload, you want to bring your app into this new environment, you're going to have to give me a manifest of how the application communicates so that I can generate the rules that will allow it to communicate, because the default rule is going to drop your traffic. Okay, so how difficult is this, right? If you give me a manifest, how difficult is it for me to go build policy? Well, let's go back to SSP, because I told you SSP had a lot of value. Well, one of the things that SSP can do is I don't like that color. Too much red here now. Change this. So SSP can actually ingest a CSV file. So now all I have to do is say, hey, you want to be in my environment? I need you to give me a CSV file in the following format. I'll be able to ingest that CSV file into SSP, and then SSP will rule recommendations that we need. So again, the common theme here is, after years of talking with customers about what are your struggles, what would make it easier for you, now we're engineering that into the product. We're trying to make this the easiest, the fastest way for you to buy down risk in your environment. And if you need that justification, then you run the segmentation assessment. If you already know, hey, look, we're not doing anything, we don't have any policies, I know what a segmentation assessment is going to tell me. It's going to tell me that it stinks because I haven't done anything. Well, then you start right here at number 2 and go with that. So we just want you to have the tools, because I have met with customers that say the segmentation assessment is critical. The segmentation assessment has tremendous value because it allows me to go to my leadership with proof that we absolutely must be doing something to control lateral movement within the organization. I need something to show them that says we are vulnerable. We are exposed to an attacker's ability to move from system to system because we're not controlling the traffic flows. All right, well, let's press on here. So greenfield, brownfield, either way, right, you have the ability to manipulate the default policy however you would like to. Let's go back up here. So let's talk a little bit about NTA and NDR. I'm going to do those in green. So NTA, network traffic analysis. With all of these flows that we have inside of SSP, obviously there's tremendous value in being able to create rules, to create policy, take the manual effort out of policy building. But we can also apply machine learning to this to better understand what's happening in the environment. So network traffic analysis, or NTA, will look at this flow information and apply machine learning to it to identify if there are anomalies that are happening in the environment. Are there systems, are there two VMs that all of a sudden started talking to each other that historically have not talked to each other? Because if I'm interested in security, I kind of want to know that. I want to know, did something change in the application architecture that is now requiring these two things to talk to each other? Or is this malicious? Is this something that should not be happening? Again, that value of SSP, the data. Data is king. All this information that we can look at, and we can help the virtualization team better understand what's happening and better protect what's going on in the environment. Now, NDR takes us a step further. NDR says, well, you got all these flows. So why don't I, instead of looking for anomalies, right, these one-off things, what if we apply AI and ML to look at the flows and then correlate the traffic patterns of particular flows and identify that there's actually an attack campaign going on in the environment? So NDR is looking at multiple flows. NDR sees all these different things that are happening, and it actually maps them back to the MITRE ATT&CK framework. But it would be able to tell you, hey, it's VM9, and it was compromised by, some command and control software at a particular time of day on, November 6th. I think today is the 6th, or whatever day it is. And then we saw lateral movement, and then it was, VM13 that was compromised. We saw command and control traffic at this time. So NDR is building a full timeline of an attack, and we roll that up into what's called a campaign, so that you have a solid look of exactly how something went down in your environment. Now, why is this critical? Well, if you think about it, now, remember, DFW, gateway firewall, all the 1, 2, 3, 4 stuff, those are all proactive steps that hopefully could eliminate or reduce the possibility that this even happens. Those are proactive measures. But in the event that something happens, because maybe we can't protect everything in the environment, but in the event that something happens, if I need to recover from an event, right, recovery is critical. Now, you hope that all the time you invest in building recovery, and that is, having an integrated recovery environment or a clean room, and your immutable backups. If you have all of these things, but you don't have this, if you don't have the information on the attack, then your mean time to recover is going to be significant. Because now you have to figure out what happened. You have to figure out what systems were impacted by this campaign. And then you have to figure out, when did it happen? So I might have a virtual machine 9, and after 3 weeks, I figured out that it was impacted. And for virtual machine 9, I've got a whole bunch of backups, but I don't know which backup doesn't have the command and control software that was installed by the threat actor. So I got to start testing. Nope, not that one. Nope, not that one. Nope, not that one. Nope, not that one. So imagine having to do this over n number of virtual machines because you don't know what happened. Whereas if I take the data that I get with NDR and I bring that data into my recovery situation, well, now I know it was VM9 and it was 11:38 a.m. on November 6th. So all I got to do is go find the backup that happened just before that and restore that back into my infrastructure. So the mean time to recovery is reduced significantly when you have a rich contextual understanding of what happened in the attack. Now, the last piece that I'll talk about is IDS IPS. And IDS IPS is available in two formats. One, in a distributed IDS IPS that runs in the hypervisor, and the other is an IDS IPS that can sit in the gateway firewall. So two different functions. But let's focus on the distributed one, right, because we all love our hypervisor. So the distributed IDS IPS, like the distributed firewall, is happening in real time in the hypervisor. So we're not adding an IDS IPS out here where we have to egress and hit a physical device only to determine that it should be blocked. There's certainly impact to performance if that's what we have to do. By building it into the hypervisor, we are now stretching the IDS IPS capability, like the firewall capability, across n number of hosts in your environment. So you build policy that says, I want IDS IPS on these particular systems, not something you turn on everywhere, but something that you want to curate and apply in specific areas where you need the additional security. So the last point I'll leave you with is this, because I think it's for us as virtualization engineers, it's really critical. You have your data center, right? And I've got n number of hosts in my racks. And this is how we've designed. And then underneath that, we have all of our physical network. Let me explain real quick why this security makes it so easy to scale the data center. So in these racks with gear, let's say it's time to grow. And whether you grow by adding one server, or whether you grow by adding an entire cluster, or whether you grow by adding an entire rack, what happens now is every new node that you add into the environment, you are going to get more compute resources for sure, which is really, that's why we've done it historically, right? Because I want more CPU and I want more memory. But now with this new architecture, every new node you add, you are also adding more security capability because you're getting more distributed firewall. You're getting more distributed IDS, IPS. And this makes it very easy to scale the data center because the core components of what I'm trying to build are all scaling linearly together. I don't have to try and figure out what capacity do I need for a physical firewall? How many of them should I build? I know what I may need today, but I don't know what I'm going to need in 6 months, 8 months, 12 months, 24 months. Well, now I don't have to deal with that. And ultimately, because we don't have to deal with that, what it means is that our physical network, all we want from it is to pass packets. I don't need to expect anything out of my physical network other than passing packets. And that should sound familiar because guess who else's physical network just passes packets? The public cloud. It's exactly what happens in the public cloud. You go into the public cloud, you're not calling and asking for VLANs. They're not managing the physical network every time somebody deploys a new EC2 instance or a new container or a new VM in GCP. That doesn't happen. The physical network is there as an SLA and has an SLA. This is just pass my packets, make it static. I don't want to have to touch it, make it stable. I don't want it going down. And that's what we want for customers. We want you to be able to quickly secure your infrastructure, vDefend 1, 2, 3, 4. But we want you to take that architecture and we want you to extend the benefits of that architecture into the other areas of your private cloud that are going to impact that operational model. And you've probably heard Paul Turner, you've probably heard a lot of people talk about the private cloud is not a destination, it's an operational model. But in order to reach that operational model, you have to make your private cloud look like the public cloud. And you have to change the mindset that you have towards the different architectural components that are in that private cloud environment. Okay. With that, I will say thank you again for attending this VMUG Global Virtual event. And I hope to see you guys at the VMUG Connects next year.